Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. In the previous video, we applied the test to a formula and we found out that that formula passed the test. In this video, we're going to look at an example of something that doesn't pass the test. Having done these two instances, we'll then go on to start proving some theorems and some lemmas that I promised you absolutely ages ago. We're almost there. But let's get going, bring up the whiteboard. So remember that the basic structure of the test is that we've got this formula. It's in ordered modal conjunctive normal form, so it's a first degree formula, and each one of the conjuncts has this particular structure where we've got all of the propositional bits first, and then all of the necessity bits, and then one single, or at most one single possibility bit. And this is the structure that each conjunct of potentially multiple conjuncts in a conjunction has. So our example sentence this time is going to be necessarily not P or possibly not P, and necessarily not P or necessarily not Q, and necessarily not Q or possibly not P, and necessarily not Q or necessarily not Q. So we've got one big conjunction. It has four conjuncts. So conjunct 1, conjunct 2, conjunct 3, and conjunct 4. And you'll remember that in the test, we test each conjunct individually, so we can ignore 2 to 4 and just look at 1 to start with. But every conjunct has to pass the test in order for the entire formula to pass the test, which means that if we find one conjunct that doesn't pass the test, then the entire formula fails. So let's look at conjunct 1. We've got one necessity statement and one possibility statement. So you recall that what we do is you take the purely propositional part from the necessity statement and you disjoin it to the purely propositional part of the possibility statement. So we've got not P or not P, and ask, is this a tautology? No. So this is a very easy example. Conjunct 1 fails the test. The entire conjunction fails the test. However, let's go on and test the other conjuncts just so that we can see more instances of how the test is applied, so you get a bit more practice. So looking at conjunct 2, again, we look at, for each one of these necessity formulas, and here we have 2, we take the purely propositional part, so not P in this case, not Q in the other, and we disjoin it to the purely propositional part of the disjunctive subformula, which there isn't any right now. So this is it. For conjunct 2, we just look at not P and not Q and ask, are either of these a tautology? And guess what? No, because no atom is a tautology. So conjunct 1 fails the test. We could stop there, but hey, conjunct 2 also fails the test. Here we've got, again, one necessity formula. So conjunct 3, we're going to be taking not Q and disjoining it to whatever we have in the possibility formula, which we happen to have. We have not P. Is this a tautology? No. Okay, and now we've got, again, 2 necessity formulas, no possibility claims to disjoin them to. In conjunct 4, we would just be testing not Q and then not Q again. Neither of these are tautologies. So in fact, every single one of the conjunctions here fails. So this is nice because then it means if for some reason we hadn't tested conjunct 1 first, if we tested conjunct 3 first, we would have gotten to the same answer just as quickly. So again, you only have to show that one of the conjunct fails in order to show that the entire test, that the entire conjunction fails the entire test. But I gave you an example of all 4 of them just so you can see how this works. So just to refresh your memory, we are going through all of this because what we want to be able to show is that if a formula passes the test, then it is provable in S5, but also the other way around. If it is provable in S5, then it passes the test. So we're going to have this very strong correlation between passing the test and derivability in S5. This is what is going to eventually get us completeness. Completeness in a constructive fashion, because for any formula whatsoever, you will have a fail-safe, guaranteed, foolproof mechanism that if you start at the beginning and you trace it all the way to the end, you will be able to tell whether this formula is a theorem of S5 or not. And if it isn't, you'll be able to give a counterexample. How exciting is that? In any case, we'll start proving some interesting theorems next time, so join me then. Until then, take care.